Hello, my name is Megan Evans, and I will be talking about my experience as the teacher in lab activity number 2. The lab activity that I completed was a candy chromatography lab, and that was a kitchen lab, and I will include a link to the lab that I actually did below. So with it being a kitchen lab, the materials that I needed were all common household items. So I needed tin foil, I needed toothpicks, a coffee filter, a cup, salt, water. So things that I had around the house. The only thing that I had to purchase was a bag of Skittles. And one of the options with this is you can use Skittles, you can use M&Ms, anything that had any type of candy that would have a dye, and you would have several different colors of that candy. So there are multiple options for that as well. So maybe you don't even have to go out if you have one of those things available. One thing that kind of bothered me a little bit because of my experience in a formal lab, teaching lab, doing labs in college, I was kind of wanting some more equipment. So I would have wanted a graduated cylinder because I would have wanted my volumes to be more accurate than what I was getting off of, say, a measuring cup, or using a pipette to get some liquid from one place to the next, and using a glass stirring rod instead of using a toothpick, I think would have allowed me to be a little bit more precise with transferring the dye from the Skittles to the filter paper. So not things that are required, but coming from someone with that background, these are things that I would have desired. And if I do choose to do this in my classroom, I will have my students use those resources that are available to them in the lab instead of ones that they would have to use at home. So here's just a picture of starting. You can see the different Skittles on the page, and underneath of them you'll see a little bit on the outside edges here starting to run. So the first step was putting some water on the foil and then setting the Skittle in it, and I was actually pretty surprised at how quickly that dye came off of the Skittle. And then you just use the water and dye mixture in the further steps. So repeatability. So this lab can be repeated, but you must start completely over for the most part in terms of what steps you're going to be doing. So there's not a back button, there's not an erase. So if you put the wrong colored dye on the wrong label, there's no going back from that. So there's no possibility to pull it back out and try again. You would just have to start over from scratch. Maybe you don't have to pull the dye off the Skittles, but you're going to have to make a new piece of filter paper. So it kind of depends on which step is disturbed as to what the impact is going to be done. So if you mislabel your filter paper, then that's all you have to do. But if on your last round of adding the dye to the filter paper, if you put the wrong one on the wrong dot, you have to start completely over. So paying special attention to details, I think, is one of the important takeaways from this, because it is something that can quickly go from being on track to having to start over. So with an example of starting over, I did not start over. I probably should have. Like right here, I got an extra green dot. It dripped off of my toothpick, or I don't know how it got there. So that's something you would want your students to redo, because you don't want that messing up where this red line is going to be going, which is going to be up. My orange dot was a little bit too big. The directions said to make them between or up to 2 millimeters, and for some reason that orange just kept getting larger and larger and ended up being about 5 millimeters. So that's another situation where maybe that's something you want to go back and repeat so you have a little bit more accuracy in your results. So in comparing this to a campus lab, I've actually never done a chromatography lab in terms of this. So I watched a few YouTube videos, and I didn't watch any with using Skittles or M&Ms such as the lab, but I did watch some chromatography using markers, and that is what this picture is showing here. These are results of different markers using the same techniques that were used during this the candy lab that I used. And what I noticed was using these markers gave a more distinct result than what I got using the candy. So you can see here is immediately after pulling it out of the water. What I thought was neat is that spot that I really should have redone right here, that was that green spot. You can actually see the blue coming out of the top there if you look pretty closely. So it was a mistake that I should have redone, but it gave me some pretty cool results, so that's kind of neat. Here is a picture of it up against a lamp. It shows a little bit more color, but if you notice, those ones in the picture from the marker were just sitting there. It's a lot easier to see, a lot easier to distinguish. So through the lamp, you can kind of see the blue comes all the way up to here on these green lines. So the green got split. Oops, sorry. The green got split by the fold in the paper, and then it continues up here. So you can see it a little bit on there. Then the timing through the whole thing, it took maybe half an hour, minus that final drying time. I let it dry for about an hour afterwards. I'm not going to include that in my time for the students because that could be a drying overnight and reading the next day thing. So 60 to 75 minutes. I was able to work a little bit ahead and faster because I understood and knew what was going to be happening and what the purpose of every step was going to be. So I think that allowed me to work a little bit quicker. Some of the directions were not very clear. I think what helped me was my experience with chemistry, like I said before, allowed me to understand what was supposed to be happening, therefore understanding what I should be doing. So if I were to adapt this lab into my classroom, I would be changing around some of the wording and making those directions a little bit more explicit so students are able to understand that. None of the steps that are done are difficult. It's really transferring dye from that foil to the filter paper, letting it dry, transferring from foil to filter paper, letting it dry, putting that filter paper in the water. However, like I said earlier, not following directions can quickly lead to having to restart the experiment, not paying attention to what colors you have where, and allowing dyes to drip or poking holes in the paper or folding it incorrectly. A lot of things can lead to that. So that's why I gave students some more time on that, because lending for possibility that this may have to happen. They may have to restart their experiments. In terms of issues, I had no problems completing the lab, no problems finding and being able to use the materials. Everything went pretty smoothly with that. I just had that personal desire to use different tools that would have allowed me to feel as if I was completing it a little bit more accurately. So those tools would have allowed for a little bit more detail in my own opinion. But it's not that it was not possible without them. I just would have felt a little bit better using them. As I said before, directions were not clear, and my interpretation came from experience in the lab, which our students may not have at that point. They may not have used filter paper before and understand the ideas and actions of capillary action for this to work. So I think that would be an issue if I were to give it directly to them. And then also the fact that the data was difficult to read. The colors were very, very faint. I'm not sure, maybe with M&Ms it would be a little bit different. That's something that I would have to try out and see. However, I think I would probably lend it to using the markers, just because I've seen through looking at the YouTube videos and looking at different pictures that did give pretty good results. In terms of what product I would ask for from my students, as a department at my school, we assign lab reports for the most part in lab activities and things that students complete prior to the lab. So this is what we call their pre-lab. Generally, there are a few sets of questions that will get them starting to think about the content, but things they have to have done before is they have to have their purpose done, their hypothesis, materials, procedure, and drawing of data tables. So obviously the input of the data will happen during the lab, but then they're not creating a data table at the time of lab. It's already done for them, and then it's just an input from there. So students will complete data table. In this case, it would have been just general observations. What did you see when you put the dots on originally? What happened as the filter paper was in the water? What colors did you see at the end? And just observational data. And then there is a little bit of room for quantitative data. They can measure the distance that the different colors traveled through that filter paper as well. And then after students complete the lab, they complete analysis questions, a conclusion section, and a reflection section after the lab. Students will be graded on a rubric that is used by the entire science department. So our rubric is a general rubric. Things can get changed because from lab to lab you have a different emphasis, and every lab is different, so every rubric should be different. But this is just a general guideline, so students are familiar with it as they travel from one science class to the next. So I've included a picture. This is one part of the rubric. If you can just pause this if you want to take a little bit more time to look at it and see how we generally grade our lab rubrics. Then here is the rest. This is the back. It all doesn't fit on one page. So here you have your analysis, conclusion, reflection, and then the general format of the lab report. Students do get points on having those things completed as well. If you are interested, if you want a copy of this, you just send me an email and I can send you a copy in Google Docs. We have found that this format has very much helped tie the department together. It makes students very aware of the expectations from course to course. And through this initiative, which we have just started a few years ago, we've seen a huge increase in students' abilities to write scientifically as well. My experience with the lab as the teacher, so I've said this a few times already, the students will need a little bit more explicit directions, giving them a lot more detail and understanding with each of the steps. One thing that's nice is it is a safe experiment. There is very little safety concerns. No glass is being used. It's water, salt, and then the Skittles. So nothing with a safety concern. Also, it's a low budget lab as well. Something that can easily be put together quickly. Provides experience with a technique and skill not seen normally in a chemistry classroom. We do not do a lot of stuff in my chemistry classroom with chromatography, and I think it allows them to see what it actually is, and it allows them to understand that there is a different way to divide out mixtures than evaporating or filtering. So it gives them a hands-on with that in a very simple way. I also enjoy this lab because I think it gives a lot of possibilities for extension and fostering student curiosity. You can allow students to bring in their own materials and see what colors or what dyes are present in the materials that they would like to see. And I think that that allows students to foster their curiosity. They can be a little bit creative, and it gives it a little bit of a personal touch. And then also it has the ability to adapt and change to meet the needs. So one of the things is it's easy to just change that to markers if you're looking to get a little bit different of a results than the candy. And it's not a difficult lab to do, so even those students on the lower end, the ones that are not great in lab, it's not a huge deal. If something goes wrong and they have to restart, it's not going to take too much time. And so I think it would also be a good lab to do at the beginning of the year to allow students to practice following directions, and seeing that not following directions can cause you to have to go to the beginning, and it makes them read and be a little bit more in tune with what they are doing as well. Then here, the Ohio Revised Standards for Science. This is classification of matter. Briefly in there, it talks about physical properties can be used to separate substances and mixtures. That's down towards the bottom. But that is all for the connections with the standards. And that has been my experience as the teacher in Lab Activity 2.